Assalamualaikum. So today I'm going to present about IBS, which is stand for Industrial Building System. First of all, I would like to introduce my name is Muhammad Hadif, and this is my group members Alif Hakim, Abdul Aziz, and Joel Adrian. For the introduction, what is Industrial Building System? Industrialized building system is a construction method in which building components are manufactured in the controlled environment or in the factory, either on site, and then it is transported to the construction site for installation and assembly. IBS replaces much as traditional on-site construction process with prefabricated components, resulting in a faster construction, a better quality, and reduced labor requirements and less material waste. It also improves the safety on the site. It is widely used in Malaysia to increase productivity and support sustainable construction practices.
Okay, moving on to our case study, we are looking at Prima Alam Damai in Ceras, Kuala Lumpur, Malaysia. So this is an affordable housing development built under the Prima program for middle-income Malaysians. The key highlight here is that it adopts the industrialized building system IBS, specifically using precast concrete technology. This approach was chosen to drive better construction efficiency, improve quality control, and ensure more sustainable building practice. So next is construction method. Let's break down the construction method into 6 clear steps. Number 1 is site preparation. So this involves clearing the land, setting out the exact building grid lines, and putting up temporary site facilities. Number 2 is foundation works. The team then excavated for the pile caps, installed the reinforcement steel bars, and poured the concrete. Number 3 is IBS component installation. So this is the core of the IBS process. Precast columns, beams, slabs, and wall panels were delivered to the site and installed using a mobile crane. Number 4 is jointing and connection works. Once the components were up, the joints were grouted to strengthen the connections, handle load transfers, and prevent water leakage. Then number 5 is finishing works. So this step covered the internal details, including plastering, ceiling works, and installing plumbing, electrical wiring, doors, and windows. And the last one is external works. Finally, the project concludes with drainage installation, roadworks, and landscaping.
Next, I will explain the equipment and machinery used in this IBS construction project. The first equipment is the mobile crane. It is used to lift and install precast concrete components safely and accurately because IBS components are large and heavy. The second is the concrete mixer truck. It transports ready-mixed concrete to the construction site for in situ works such as foundations, columns, and floor slabs. Next is the excavator. It is used for earthworks, site clearing, and foundation excavation before construction begins. The lorry is used to transport precast IBS components from the factory to the construction site. Proper transportation is important to prevent damage to the components. Lastly, scaffolding provides a safe working platform for workers during installation and finishing works, while also improving access to higher areas. Next, I will explain the site coordination and management process. First, component deliveries must be properly scheduled to avoid congestion on site and ensure smooth operations. Second, the factory production schedule must be coordinated with the installation activities on site. This helps prevent delays and ensure that components arrive at the right time. In addition, daily site briefings and safety toolbox meetings are conducted to remind workers about work activities, safety procedures, and potential hazards before work starts. Finally, quality inspections are carried out before and after installation to ensure that all components meet the required standards, are installed correctly, and maintain both construction quality and site safety.
Moving on to a crucial part of our discussion, the problems and solutions surrounding industrialized building system or IBS. While the benefits are many, industry players still face a significant bottlenecks on the ground. Firstly, we have the high initial investment costs for setting up factories, specialized small and heavy machineries. To reduce this financial burden, we can utilize government incentives, tax exemptions, or encourage contractors to share facilities and form a consortium to split overhead costs. Secondly, there is a lack of skilled workers and technical expertise in precise IBS installation. To bridge this skill gap, companies must provide a regular training program and certification courses for their workers. For the third problem, transportation difficulties. It often arises when moving large heavy precast components to site, especially in remote areas. We can solve this by improving logistic planning and using suitable transport vehicles or establishing a temporary casting yards closer to the project site. Our fourth challenge, it is poor coordination between designers, manufacturers, and site teams. Because IBS has a zero tolerance policy for design errors, we must implement building information, modeling, or BIM, and conduct a regular coordination meeting to run automated clash detections for casting begins. Finally, we hit limited acceptance and awareness of IBS benefits among some contractors and clients. To shift this mindset, we need to increase public awareness with campaigns, showcase a successful project as proof of our concept, and promote supportive government adoption policies. Now I am going to talk about regulatory compliance, CIDB. What is CIDB? CIDB stands for Construction Industry Development Board. From CIDB, IBS is strongly encouraged and widely promoted, especially in government projects. Projects are evaluated by using the IBS score system to measure the IBS usage level. Contractors must be registered under CIDB grades G1 to G7 to carry out construction work. It is to provide standard CIS training and certification for IBS practices. Regulatory compliances by UBBL, also known as Uniform Bylaws 1984. IBS structures must comply with UBBL requirements. It must have structural safety, fire safety, and escape routes. It has minimum space requirements and building height regulations. All IBS buildings must still be approved by the local authorities, or also known as PBT. Regulatory compliances by OSHA, Occupational Safety and Health, Act 1994. IBS improves safety by reducing on-site hazardous activities. It has less manual work, such as bricklaying and formwork at height. It has standard operating procedures, SOP, personal protective equipment, PPE, such as helmets, vests, and harnesses. It has regular safety inspection and audits. CIDB also supports safety training programs such as CSHO.
Sustainable aspect of IBS construction. Number 1 is waste reduction. The components are manufactured in factories with precise measurement and minimal material wastage such as cement, timbers, and bricks. Number 2 is reduced environmental pollution. Less dust generation at the construction site, lower noise pollution due to reduce on work site, and reduce air pollution from fewer heavy machinery activities, and a cleaner and more environmental friendly construction process. Number 3 is energy and carbon efficiency. The factory production can improve efficiency because it can reduce the use of heavy machinery on site and lower the carbon footprint compared to traditional method. Number 4, a faster construction time. The shorter the project duration and the less environmental impact due to reduced site activity time. Number 5 is a better quality and durability. The control factory condition to ensure the consistency of the quality and the higher durability and the longer the building lifespan. For the conclusion, IBS is an efficient and modern construction method that improves the quality and reduce the construction time and minimize the labor requirements, although there are some challenges, they can be overcome with the proper planning and technology. And the Prima Alam Damai project shows that IBS is practical and sustainable solution for delivering the quality and affordable housing in Malaysia.